Welcome to Lecture Online. Now let's put into practice what we've learned so far. What we're going to do here is, starting with a quarter circle, take a whole bunch of different kind of shapes and find the center of mass or center of gravity of each of those shapes. In this case, we're going to start with a quarter circle. How do we find the center of gravity of the circle, or the x and y coordinates of that center of gravity? Well, we have the equation here where the x coordinate is equal to the integral of the x coordinate of each little piece divided by the total area, and of course we integrate the numerator. We can also find the same thing with the y coordinate like that. And because of the shape of this quarter circle, the value for the x coordinate and the value for the y coordinate will be exactly the same. So we just only have to do one, and then we know it for both. How do we do that? Well, what we're going to do here is we're going to take a small little slice, and this little slice will be our small little dA. Notice that dA is equal to the height of that slice, which would be equal to y, times the width of the slice, which would be a small little dx. So this here is a small little dx, and the height is a small dy. And we can take the x and y coordinates of that little point, so this would be x, and the y coordinate of that little slice. Now it makes more sense to deal with the y coordinate. What we can say is that the y coordinate of that little slice is equal to the full height divided by 2. That will get us right in the halfway point, so that would be y divided by 2. So what I think I'm going to do in this case, since it's when I set it up like that, I'm going to solve for the y coordinate. Now if I had made my little slice sideways, then I would have been able to solve for the x coordinate, and actually it's exactly the same methodology. Let's go ahead and do that. We're going to find our y coordinate that is equal to the integral of the y coordinate of that little segment, and the y coordinate of the little segment is equal to y divided by 2 multiplied times my dA. My dA is equal to y times dx, and then we take the whole thing and divide it by the area of a quarter circle. That would be 1/4 times pi r squared. Pi r squared is the area of the full circle. 1/4, that will be the area of a quarter circle. Notice that the radius of the circle is equal to r. Also notice that if this was a complete circle, the center of the circle would be at the origin of my coordinate system. Now notice that this will give me, let's see here, if I put the 4 on top divided by 2, I can say this is equal to 2 times the integral of y squared dx divided by pi r squared. So I took the 1/4 in the denominator, moved the 4 to the numerator, so 4 divided by 2 is equal to 2, and I still have y squared there. But now notice I have a y squared and a dx, and I cannot integrate that because those are different variables. But I know the equation of the circle. The equation of the circle can be written as x squared plus y squared is equal to r squared, which means that y squared is equal to r squared minus x squared. And I can substitute y squared for r squared minus x squared. When I do that, I get the following. This is equal to 2 times the integral of r squared minus x squared times dx divided by pi r squared. Now I can go ahead and integrate the numerator. So this would be equal to 2 times, when I integrate this, I get r squared times x minus x cubed over 3, evaluated from, well, what are my limits? I'm integrated from 0 to r in the x direction. So my limits will be from 0 to r, and so this will be from 0 to r. And then I divide that by pi r squared. When I plug in the lower limit, of course I have a 0 minus 0, that gives me 0, so I don't have to worry about the lower limit. But when I plug in the upper limit, I will get 2 times r squared times r, which is r cubed, minus r cubed divided by 3, all divided by pi r squared. Now I have an r cubed minus 1/3 of an r cubed. That's 2/3 of an r cubed. So this is equal to 2 times 2/3 of an r cubed. I have parentheses, no longer brackets, divided by pi r squared. Notice the r squared divides into the r cubed, so this cancels out, and I get rid of 2 of those. 2 times 2 is 4, so this is equal to 4r divided by 3 times pi, and that would be the y coordinate of the center of gravity of this particular object. And because of the perfect symmetry, I know that the y coordinate will be, or the x coordinate will be exactly the same thing. So therefore I can say that in this case, the x coordinate and the y coordinate of the center of gravity is equal to, that would be 4r divided by 3 pi for the x-coordinate, and 4r divided by 3 pi for the y-coordinate. And that's how we utilize those equations to solve for the center of gravity of a quarter circle.